So now we're going to take a look in StatKey at editing data. So if we go into StatKey and start doing something, let's say I'm looking at one quantitative variable. Here we've got a data set for mammal longevity. So we've got, if we look at the data table, show data table, it has different animals and their life expectancy. All right, so these different animals. Well, say I wanted to enter my own data. So I wanted to not create a data set, but just do some simple data analysis for a homework assignment or something like that. So what we can do is, here's this tab, Edit Data. And this goes to the data that's available, and you can change this manually. So I can left click and scroll down, and I can select all of that information and delete it. Okay? And what I can do is, so now I can enter my own data. So these two buttons down here, or these two checkboxes, one says first column is an identifier. If I'm just have a list of numbers and I want to find standard deviation or something like that, or the mean, I don't need a first column, and I don't necessarily need a row header. This would be, so back when we had the data table, we had the animal and the longevity. That was our header row, which identifies what's in the two columns. And the first column is always something that is the identifier, and the second column would be the quantitative variable that you're actually analyzing. So if we unclick both of those, I can just type in numbers, 12, enter, 45, enter, 18, enter, 76, enter, 56, blah, blah, blah. And as you'll even see as I'm entering numbers, entering random numbers is really hard. You think you're trying to be clever and I'm doing another 70. It's really hard to do random numbers. So there's my data. So I enter these numbers from some data set or some homework assignment and click OK. Now my data is in there. So there are 13 values. It calculates the mean, it calculates the standard deviation, and it calculates these summary statistics for the 5-number summary. Okay, so now the histogram isn't going to be that meaningful necessarily because I have a relatively small number of data values. So here you got 2, 2, 2, 2, 1, 1, 2, or 3. That's not that exciting. The box plot isn't that exciting either, just because we have so few data values. But if you're trying to do something quick and simple like this, I'm just doing these couple of things. I just want a mean, I want a standard deviation, I want the median. This does it for you. You can do it in Excel as well, but if you're playing with StatKey, it's an easy way to get your own data analyzed. So another nice tool that we can use to analyze data of our own is using our friend Excel. So using Microsoft Excel, what we might do, category and age. So we've got best actress, we've got a bunch of ages. So looking at I'm just going to fudge some numbers here, 25, 40, 31, 37, 27, 29, 34. Okay, so I'm just going to create a data set this way. What you'll end up doing is entering all your data the right way. I'm going to cheat here a little bit. just so I have a good sized data set. So now I got 85 data values for Best Actress. What I can do is do Control C and paste, and then I can choose all these cells underneath it. And so now I've got Best Actress and all the associated ages. Now what I could do in this same data set is type in the ages of males. So I'm going to do those here. So you'll actually, unfortunately, have to enter all your data values, but it's not so bad. It's, as a data analyst, at some point, if you're doing some data analysis project for some other class, you're going to have to enter your own data. So this is good. This is good practice. So now I have this data set. It's all the ages done by Best Actress, Best Actor, and their ages. What I'm going to do now is save this data set in a format that can be input to StatKey. So I'm going to click File, Save As. So I'm going to save this as, practice data set. You can name it anything you want. Okay? And the type to save as is this thing, a comma delimited file. So you go down in this list to CSV, because that's it's a special kind of Excel file, but it can be imported into StatKey. So I'm going to save that. Blah, 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 blah. Say OK, yes, done. Okay? So now, someplace in my computer lives this file. So now I can use that data. So if I go to one quantitative variable, I've got my mammal longevity. So I can upload file. So I find my file, I select it, hit open. Here's my data, and it says please select a quantitative variable. So I click on age, left click on age, and hit OK. So now what it says is practice data set age. So here's the dot plot. So I've got all these values done. It's got sample size, the mean, the standard deviation, the minimum, maximum, those 5 numbers. I can draw a histogram. What's my histogram look like? Etc. I can do a box plot. Looks like that. So this, just looking at this, it seems to be skewed to the right because there's a much larger range for the top 50% than for the bottom 50%. Anyway, and here, depending on what your data set looks like, you can change columns. Okay, so I could, if that were another quantitative variable, I could select that. Okay. So we can do that for one variable. Now we can use this, one quantitative and one categorical variable. It knows what to do. So this column click, or what does it say? Change columns. I can go in here if I had a larger data set. I can pick a quantitative variable and then a categorical data variable, and it would change what I have. Okay, but here, what we can do is do these comparisons. Here I've got Best Actress. Here I've got Best Actor. It's got the mean age, got the standard deviation, and then the 5-number summary. So here, just making some comparisons, the median male age is 41 versus 29. The mean is 42 versus 29. The standard deviation. So looking at these, it seems best actors, older, standard deviation is greater, much greater, so age is more spread out. So, and looking at the dot plot, looking at the histogram, okay, let's change the number of buckets to 7, okay. Males look pretty uniform, but spread out much more. Females are all, so between 23 and 37, small range. Males between 25 and 61. That's a much greater range, so it's going to be the higher standard deviation. They're more spread out. Okay, so that's using data of your own. Okay, so we can upload files and do all that kind of fun stuff. Another thing you might want to do is look at different analysis for data sets that you see in the book. So we had for the student survey, you can look at hours of TV and hours of exercise. What if you wanted, as we did earlier on, we could look at number of piercings, we could look at SAT scores, we could look at GPAs, any of the other variables we wanted to in there. Okay, so what we can do is, here we've got data sets. And when we click data sets, it has a list of all the data sets that they use in the book. And what happens is they're done in different file types. So for different kinds of, so text file, here's an Excel file, here's that CVS that we looked at. And then these are for different statistical packages. So what we can do is we can go down to the student survey and download this CSV. So what it'll do is it'll download to my computer, student survey. I'm going to put it in there. Now I've got that data set. Okay, so I can close that. And now I can go back to stat key. If I've got one quantitative variable, upload my file. Okay, so there's my data file. And what I can do is select a quantitative variable. Height. So now I've got a data set, and I can do analysis on any of these columns. So height, as we kind of talked about before, this looks like a normal bell-shaped curve. Histogram, let's do 7 buckets. Yeah, looks kind of symmetrical. Maybe a little tail over here, but pretty much what we might have suspected. Looks pretty symmetrical. Bottom 50%, top 50%, roughly the same. Okay. And over here we've got mean, standard deviation, and the 5-number summary. Okay. I could then go to this, one quantitative and one categorical. So this is TV by gender. I can change columns. Here's that data. I pick a quantitative variable, piercings, and a categorical data, gender. Click OK. And now there's my analysis for piercings. So as we saw kind of the first week or so of class, average for females about 3.4 piercings, males about 0.2 piercings. Minimum of 0, maximum of 5 here. Females maximum of 10. The median for females is 3, so half of the women in this survey have less than 3 tattoos. Half have more. Okay, males, half of them have 0. We look at this histogram. 6 buckets. Males, frequency 185 out of 192. So over 90% have no tattoos. So, 0 or 1. If we go back to the dot plot, it looks like, we can't see the scale, but lots and lots of 0, some with 1, some with 2, 3, 4, 5. Okay, so we can do some comparisons for the males and females, the 2 box plots. Not much for men because there's basically only 1 value in there. But I could change tables. I could pick, let's see, GPA and gender. Maybe there's some relationship there. Means a little higher for females, roughly the same standard deviation. Okay, so they're close. We can make that comparison. If I went back and did 2 categorical variables, I could look at, let's see, I can go to my student survey, award by gender. I can change columns. Maybe I'm going to do gender by smoking. And I'm going to do row proportions. 14% of males are smokers, 9.5% females are smokers. Is that a significant difference? I don't know. Is year in school and whether you smoke or not, is that a relationship? 13% of seniors, 11%. So the highest is for juniors. So first year, 10.6, then it goes up a little. Junior year, it goes up a lot. It tapers off. I don't know, maybe that's significant, maybe not. So 2 quantitative variables. And I'm going to say students. I'm going to upload my file, student survey, and I'm going to pick GPA and SAT. I think there might be a relationship, but maybe not. Maybe it's just all over the place. Maybe there's a relationship between hours of TV and GPA. Nah, doesn't look like anything. A bunch of stuff. Okay, relatively meaningless. But the idea is that you can use your own data, put it into StatKey, and start doing some analyses that they don't have set up already.